Hello and welcome to Console Cowboys. We're going to kick this off by starting up a Brownie project and doing all of the Python interactions within Brownie to our bank smart contract, similar to what we did in section 1, but in a very simplified fashion as far as deploying it to writing our code to interacting to our private keys, etc. You're going to see it's much simpler, but we're going to go over a lot of examples so you really understand how to do this within Brownie to help out your testing methodology. If that sounds good, you can follow me in the link below on Twitter, and let's get rocking. So the first thing that we're going to do is we're going to create a directory for this project. So we'll say make directory, and we'll call it bank since we're interacting with our bank contract. We'll cd into there, and we will load up code, so that way we can see what's going on. So this is for Visual Studio Code. If you're using that, you don't have to, but it has a lot of niceties, and I like using it. So once we're in here, what we want to do is we want to open up a terminal, and we want to run Brownie init. And that will initialize our project and give us all of our starting folders. So I'm going to hit new terminal. And down in here, we'll say Brownie init. And of course, you need to have Brownie installed. Check out the previous video for that. So once that's run, you'll see a bunch of folders popped up in our Explorer. Right? We have our build folder, which will give us information once we build a contract. We have our contracts, which is where we're going to put our bank contract that we're interacting with, as well as you can do stuff with interfaces, reports, etc. The main things that we'll be dealing with here is our scripts folder, where we can write scripts to interact with our smart contract. And then we can write tests if you want to do some test-driven development, or some auditors like to write tests to confirm things that they're doing. I tend to use scripts more, but I'll show you how to do both, and you can choose whatever works for you. Now, let's find our contract here. So the contract that we're going to use is up on the GitHub page, right? So the same one from section 1 in our Python smart contract blockchain exploitation. In the part 1 manual interactions, we have our hello world bank here. So if I grab all of this code from here, this is what we're going to use. So I'm going to copy this, and then let's paste this into here. We're going to go to contracts, and we're going to create a new file. We'll call it bank.sol. You can call it whatever you want. I'm just going to paste it in here like this. And you'll notice also I have syntax highlighting. So if you are using Visual Studio Code, you can go right over here to extensions. And if you type in Solidity, you're going to get a bunch of extensions for that. If you type it in correctly, that is. And what I would suggest is install this Visual Developer, because Visual Developer will also install the language, which will give you syntax highlighting, but we'll also use Solidity Visual Developer later on for some graphing and such. We've done that in previous videos before. We'll do it again. So once you do that, you're going to have some syntax highlighting on your bank contract, which will make things easier. For those who don't remember what this contract is, this is just a simple bank contract, and we can use the plugin we just installed by hitting Control-Shift-P and typing SURYA and bring up the call graph. And this will remind you what's in this contract before we start messing around with it. So we have our constructor as always. We have an only owner for admin functionality using isOwner. We have a change message function, which we just use to look at private variable data. A deposit, withdraw, and withdraw all, which are both payable, and withdraw all goes to an address, as well as we have a get balance function. So hopefully that all is familiar to you. If it's not, go back to section 1, review the video where we looked at all the manual interactions with this contract. And now let's just compile this contract. We can do this quite easily with Brownie compile. And if you don't have the proper version of Solidity, what it's going to do is it's going to download that. And then once it downloads it, it's going to compile. So it says project has been compiled. Yours might take a while if it has to download the Solidity compiler. It could take 5 minutes, and then it'll do the same thing that it did here, because it's going to download the version of Solidity that you're using in the contract. So we're using above 8.0. So it grabbed the newest one, probably for that is 0.8.19 for the version 8. So that's all good to go now. And if we go up into build, you're going to see some stuff up in here, right? So we have our hello world JSON, which has our ABI in there to connect to there. And if you scroll down here, you're going to see, I believe, some assembly and stuff like that in here as you cruise down, right? So you just saw like push 2, C5, etc. So that's going to be your assembly. So that all goes into this build directory here. And what we want to do now is we want to take this compiled contract, and every time we want to do something, we want it to automatically load up a temporary blockchain, or we want to deploy it to a test net. You can choose what you want to do. For now, we're going to use a local Ganache blockchain, but we want this to all happen automatically so we can deploy stuff with scripts inside of Brownie, and then it'll deploy it for us. It will launch Ganache in a local blockchain, and our script can interact with it. Then it'll close it all down. And this is really, really simple to do. We're going to do this right now. So here's what we're going to do. We're going to go into scripts, and we're going to create a deploy.py for Python, since we're dealing with Python. And what we're going to say is from Brownie import. We're going to need our accounts, so we're going to say accounts. That way we can directly interact with accounts that are in Ganache. You'll see how that works. And then we need to import our smart contract. Now we named it bank.sol, but what we actually need is the name of the smart contract here, which is going to be this hello world _ bank. So we can grab this and say copy and go back into our deploy script, and we could just add that in here. So we're just going to import this, and then we have access to everything. Right, and you saw in the build directory, it just builds it in there, and we have our ABI we can interact with. So now we have everything we need to proceed. So first thing we're going to do is set up the accounts that we want to use. So we're going to say account 0 equals accounts, and we'll just say 0, right? Because the first account in Ganache is going to be account 0. Now we can use that and we can deploy it. So what we're going to do is create a main function, and then have that main function call our deploy function, which is going to deploy our smart contract. Now, this might sound a little complicated, but it's actually really, really, really easy, and you're going to love this. So we're going to say define main, and you'll notice this is just Python code. It's nothing fancy. We're going to say bank equals deploy bank, and then we have to create deploy bank, which is going to deploy our bank contract. So let's do that. So we'll say define deploy bank, and we'll put in some code to deploy it. Now this is going to be very, very simple. So you remember in Remix, we had to put all our code into Remix, and then we had to, deploy it, and then we had to cook it up to Ganache locally, and then we could use our code. We're going to do this very simple, very quickly. So we're going to say bank equals our hello world.bank. So that's the name of our contract, right, that we imported. .deploy, seeing how easy this is already. And then all we're going to do is say, well, we want to deploy it from our account. So we'll just put our account in there. And the way we do that is this. We say from, and we want to do it from our account 0. And that's literally all we have to do. That replaced, setting up a local Ganache blockchain. That replaced deploying our contract into Remix and hooking it up. That's all we had to do. We just had to say hello world bank .deploy and use our account to do it. And then we set that to a variable. And what we're going to do is return that back to our main function so that we can use it right here any way we want. So we're going to say return bank. And that just gives us a way to interact with that contract now. So now that we have this, let's run this and see what happens. So we'll say Brownie run scripts, and this will be our deploy script. So once we run that, you'll see launching Ganache on port 8545 with our gas limit accounts. We got 10 of those. Perfect. We had our bank project as our active project. We sent a transaction here and we deployed to this address. And then once we were all done doing that, we terminated our local RPC client because we had nothing else to do, right? We deployed, then we put it to this variable, which allows us to communicate with the smart contract. But then since there's nothing else to do, It tore it all down, took down our ganache. And this is very, very convenient because we don't have to go into Remix, redeploy things, press a bunch of buttons and waste a lot of time, and then manually take the contract address and paste it into our scripts. It just all gets handled for us, which is absolutely fantastic. So what we need to do now is we need to take this connection to this smart contract and interact with the smart contract. We can do that by creating another function here, passing in that bank variable, and then interacting. So let's do that. We'll call it bank interactions. And we'll just pass in our bank variable. And from that, we can do whatever we want with that smart contract. So I'm just going to copy this, paste it up here, and we'll say define bank interactions. We need to pass in our bank variable. And then we can use that to communicate. So what do we want to do? Well, if we look at our bank.sol, we can scroll all the way to the bottom here and we will see a get balance function. So let's just call that. We don't need to call it with anything. It's just going to give us the balance of message.sender, which is us, that first account there that we're using right now. So let's go back into our deploy script and let's do that. So we'll say print, and we're going to say bank dot get balance. And that's literally all we need to do. Now with the Python scripts before, we also had to say a dot call and specify that it was a call, not a transact. We don't have to do that because Brownie understands what's going on and it'll automatically figure that out for us. So since we have no balance in this now, all we did was deploy it. We should get back 0. So let's give that a try. Run this again. I'm just going to pause this till we get our output. All right, so here is our output. Again, we launched Ganache again, and then we sent a transaction. We deployed it, and after we deployed it, we called that get balance function, which gave us a 0 because we have no balance yet. So how about we deposit a balance and then we check that balance again to make sure that it updated. That way we can see that we can send value to the contract as well in a very, very easy way. So let's do that now. So what we're going to do is we're going to say bank.deposit, because that's that deposit function in there. And what we're going to do is say from, and we want to do it from our account 0. And I'm just doing this to specify it so we know what's going on. We probably could do it without that right now and it'll automatically use our account 0 because that's what we're set up to do, but we're just going to specify it. And you'll see why in a moment because we're going to use another account. And we're going to say we want the value of 1 and then 18 zeros here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 because we have the 18 decimals in Ethereum, as you know. And that should deposit 1 Ethereum into account 0. And then we're going to want to check that again. So what we can say is we'll just print out our balance again. And we can also specify it here. So this is the way to just get it with whatever our default account is that we're calling it with. We can actually specify it as well. So let's do that this time. So we'll say use an F string. So that way we can put some text with our variables. And we'll say account 0 colon. And then we will put this into our brackets for our variable. And we'll say bank.getBalance, and we're going to say from this time. So we're going to say from, just so that we specify it this time. We know exactly what we're specifying. Count 0, and that should be correct. I just need to put a closing quotation mark here for this F string. So we're doing the same thing we did up here. We're doing balance, bank.getBalance, but instead of like just saying, you know, whatever we call it with, we're going to specify it this time. We're going to say get the bank balance from account 0. And then all we did was put this in a Python F string so we could put account 0 before it so we know what we're calling, right? So let's do that now. We should get 0 back. We're going to deposit 1 Ether, and then we should get 1 Ether back from our account 0. Now this is where that whole, pi test testing can come in. A lot of auditors like to say, insert one and then assert that one was inserted. That way to make sure that the test is working. That's something that we can take a look at later. Right now, we're just writing scripts. So let's run this. I'm going to pause while it's giving output. All right, so here is our output. We see our get balance equals 0 again. And then we sent that next transaction, which added that value of 1 ether to account 0, followed by account 0 equaling 1 ether right here. Then, of course, we tore down our connection because we didn't need it anymore. So now let's see how to interact with a different account. You saw that we specified it here, which means we can specify it for another account as well. So let's copy this and let's paste it right below. Actually, we'll copy paste both of these. So let's do a copy and let's paste it down here. But let's just change this from account 0 to account 1, and then we'll create an account 1 above the exact same way that we did before, right? So we have this account 1. We're going to grab from Ganache this account 0 and we'll put it to accounts 1. So I'm going to copy this and I'm going to paste it right underneath, and we're just going to change it from 0 to 1. And then to differentiate these a little bit, I'm just going to do this with 2 ether instead. And you'll see how we, specify account 0 versus account 1 when we're making these calls, and how to send this value over, as well as how to call the get balance function. So let's run this. Now I did get a bunch of errors here, but something might have screwed up. But if I scroll up, let's see what we got here for the actual output. So we have 0, then we had 1 ether in account 0, and then account 1 had the 2 ethers. So all the output was okay, but when we terminated, we got some other errors related to something else. I don't believe that is related to our scripts. I believe it's related to just tearing it down and something happening. So no big deal. That is how we create a simple deploy script and we interact with our bank contract. I'm going to call it for this video because it's getting a little bit long now. In the next video, we'll look at some other aspects, and we might dive into the debug console so we can interact with things directly as well. Hopefully you learned something. If you did, please leave a like and a subscribe, and you can follow me on Twitter on the link below.